In this question, a scientist is carrying out a reaction and measures the concentration of rubidium hydroxide, RbOH, at regular intervals. The scientist wants to determine the average rate of change of rubidium hydroxide between 10 seconds and 40 seconds. And remember, we're entering only positive numbers for these answers. Okay, so let's have a look at our table of information. We're looking between 10 seconds and 40 seconds. And in our first column, we've got the time. And in our second column, we've got the molarity or concentration. So we're looking for between 10 seconds and 40 seconds to find the average rate of change. So our first step is finding our change in molarity. And remember, those vertical lines mean absolute value. And that means we don't care if it's positive or negative. We just want to know the amount of the change. So to do that, all we need to do is subtract our two values. So our final molarity is 5.19. That's our M2. Our initial molarity, M1, is 4.21. So if we subtract those to find the difference and ignore any positive or negative sign we might get in the end, that gets us a change in concentration or change in molarity of 0.980 molar. To find the time, we started at 10 seconds and ended at 40 seconds. So if that's our T1 and our T2, to find the time of our reaction, we're going to take the final time and subtract the initial time. So we ended up at 40 seconds. We started at 10. So the overall length of the reaction was 30 seconds. So that's how we find our change in concentration or molarity and our time. Let's fill those into our table over here. We got 0.98 molar for our change in molarity. For the time, we got 30 seconds. So those are our two known variables. Now we're trying to find the rate. So let's head to our reference sheet. Here's our reaction rate equation at the top. Rate is change in molarity divided by time. So let's write down our equation. Rate is change in molarity or concentration divided by time. So we just need to plug those values in. 0.98 was our change in molarity divided by our time, which was 30 seconds. So if we put that into our calculator, we get 0.0327 molar per second for our rate of change. So let's fill that in to check we got that right. Awesome. So that's going to be our final answer. That's what we found. And to answer what type of rate is this, that's asking us is a rate of consumption or a rate of formation. Remember, consumption means it got used up, so the concentration decreased. Formation means it got made, so the concentration increased. So if we look at our numbers here, we started with 4.21 and ended with 5.19. So that's an increase in concentration. And that means it's a rate of formation. So for this one, the type of rate is going to be a rate of formation. If the concentration actually decreased, that would be a rate of consumption. So in this question, it's just like the previous one. We're using the same equation. The only difference is that to find our change in concentration or molarity, we're looking in our table to find our initial and final concentration. And to find our time, length of time for the reaction, we need to look at the time at the beginning and the end and subtract them to get the length of time the reaction was carried out for.